Hello everyone, welcome back. We're still looking at trigonometric ratios, and last time we explained Pythagoras theorem, but now we want to focus on the trigonometric ratios. There are actually three major trigonometric ratios: the sine, the cosine, and the tangent. Now, what these tricks actually mean, they are ratios. You know, when we say ratios, we're talking about fractions. Now, these tricks help us to solve problems under right angle triangle. And there's something that can always help you remember what these tricks are, and they are called SOHCAHTOA. This is something that will always guide you to remember your trigonometric ratio, SOHCAHTOA. What it actually means is that sine theta, which is sine, but we write that same. So the sine of any angle is equal to the opposite. You see, the O means opposite over the hypotenuse. The cos of any angle is equal to the adjacent over the hypotenuse. Then the tan, that's the tangent of any angle. So cos is like saying cosine, but we use cos as short form. The tangent of any angle is equal to opposite over adjacent. Sorry, I squeezed that in. Now, using this SOHCAHTOA, if you can memorize this SOHCAHTOA, say it with me: SOHCAHTOA, 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 SOHCAHTOA. So if you can memorize this and know how to spell it, you'll be able to deal with any trigonometric problem. So now, remember, the longest side is the hypotenuse. So this adjacent, opposite, hypotenuse you are hearing, they are the names of the three sides of a right angle triangle. They are the names of the three sides of a right angle triangle. So what do they actually mean? What they mean, these are names of the three sides of the right angle triangle. Now, the hypotenuse side, we already know what it is. It is that slanted side, the longest side. So I can clean this. Let me clean this off. We already know that this is the hypotenuse. So let's call here S. Now, if here is Y and here is Z, our problem now is which of these Y and Z do we call the opposite, and which one do we call the adjacent? Which of them is the opposite and which of them is the adjacent? Can you guess? No, you should not guess. Do not guess. Now, how do you locate your adjacent or your opposite? You locate it depending on the location of or the position of the angle. You know which side is your opposite or which side is your adjacent. There is no permanent side. There is no, unlike the hypotenuse that has a permanent side, it's always the slanted side. But for the other two, they can be opposite, they can be adjacent. It has no permanent side. It depends on the position of the angle. Remember, we have a right angle here, but the other two angles we are considering is this one and this one. We don't really consider the right angle triangle, the right angle. The angles we are considering is this other two sides. So if my theta is here, if theta is here, that's theta we are talking about. If it's here, the angle we are considering, if it's here, my opposite is now that side facing my angle, while my adjacent is that side the angle is resting on. Did that make any sense? The opposite is the side the angle is facing, while the adjacent is like the side the angle is resting on. But if my angle is here, opposite becomes here, while adjacent becomes here. Now please remember this. So if you are considering this angle, sine theta, which is opposite over hypotenuse, will now be what is the opposite? Y, and our hypotenuse S. In this case, we have adjacent over hypotenuse. So what's the adjacent? Z. Hypotenuse S. Y tan is opposite over adjacent. So where is the opposite? Y. And adjacent Z. So this is how to get the trigonometric ratios using SOHCAHTOA. Remember, SOHCAHTOA is what guides us to get our trigonometric ratios. So I hope you got this. If you have any questions, ask in the comment section. Please like my videos, share, comment, help me at least encourage me if you actually enjoy my videos. So you keep saying it, encourage me, and the Lord will bless you. So drop your questions in the comment section. In my next video, we'll solve examples on this.